Welcome back. The last session was very interesting, right? See, even though you do any silly mistake, right? We got the answer. It doesn't mean that we got the answer. Fortunately, it is finding that it is wrong. Means we did something wrong. That's what I told, right? Somewhere something have written little bit wrong. If you can catch it up and then if you get the solution, I'm very happy. But I don't know, the few people still they are getting that where is the issue, and then if you didn't understand the question what I'm asking, then let's see, right? Therefore, there is some silly mistake, right? Now, even though with that silly mistake, if I continue and then say that this is the answer, no, this is not correct. After derivation, after getting a formula, remember we have to see whether it is feasible, mathematically feasible or not. That is what we need to check. I told you, right? V gamma is 0.7, VCC let us say 10, 0.7 by 10, definitely less than 1, minus 1 it is negative, log negative, not defined. Not defined, but we know that practically yes, there is a positive time t dash 0 to t dash is equal to t, there is a positive time. But mathematically it is saying wrong, means somewhere something is wrong. That is what I told while deriving itself. It was known to me, but I didn't do it because I want to explain that after deriving we should understand clearly whether it is feasible practically or not. That is what we need to have. It is something like, you remember we solved log amplifier. When we solved log amplifier using Opamp, where PN junction diode was there in the feedback, I told that only for positive inputs your output is defined. For negative inputs, first of all, that is not a log amplifier because Opamp will enter into open loop condition. Then your V0 will be either plus VCC or minus VCC. It is a comparator. It was a comparator, right? Therefore, mathematically also, sometimes the qualitative analysis will be explained. Here also it is explained. Let's see, where is the mistake? I think already few people already figured it out, the mistake is, or the correction is, what is final voltage minus VCC, right? Therefore, VI minus V final. What is VI? V gamma. What is V final? I wrote it as minus VCC, but strictly speaking, V final is minus VCC, minus of minus VCC we have to write. That is a mistake. Therefore, what is this? This is minus of minus VCC. Therefore, this is minus of minus VCC. That is what is V final. I think now everybody will understand why. Remember, if you know that there is a silly mistake, instead of seeing the derivation again and again, if you see the derivation again and again, your brain will be tracked to the derivations what you did. We have to write or we have to derive in a fresh pace, then you will get the mistake. Okay, that is what it is. Because of which, then you know what happened. This is another minus VCC, then V gamma, then it is becoming plus VCC. When this is what is plus VCC, then it is plus 1. And that is what is plus 1. This is also plus 1. And this is plus 1. Now this is plus 1. Yes, now it is positive. Satisfied. I hope everyone understood. Therefore, this is nothing but T is equal to, this is what is the formula. What is your time? Minimum time. This is what is called minimum time period. Therefore, T minimum. Less than that if you do, right, the trigger will be missed. That is what I'll explain. Okay. I hope this is done. Okay. Now, the observation is, if trigger period, right, is less than, if trigger period T less than T minimum, right, T minimum, then trigger will be missed. Trigger will not impact output. That means trigger will be trigger miss. This is what is called, your trigger will be missed. This is what people call it as trigger miss. This is the observation. Therefore, this is what is the minimum time period, which is nothing but RC into Ln 1 plus V gamma by VCC minus by 1 minus beta. Anything is fine. Okay. This is the second one. Everybody understood? Do silly mistakes not in the examination, right? Not wantedly. If you do silly mistake, instead of saying that do silly mistakes, instead of doing I can say, if you do silly mistakes, get the answer, don't leave the answer like that. You analyze a little bit, that will tell you the story whether that is correct or not. But sometimes, unfortunately, even though you do some silly mistake, you'll get answer which is like practically feasible. Then should be very careful in those cases. Okay, fortunately here it caught whatever silly mistake we did, it caught in the expression, in the equation of T minimum. Okay, that is fine. This is what is monostable multivibrator. In future I'll also do something like this, and then I'll ask you to correct it. But anyway, I'll correct it after some time. But you have to carefully observe, and because there is no two-way communication, only one-way communication, you have to write a note. Then even though I do mistake, you have to correct it. If you are able to catch means, indirectly, that is what is indirectly saying that you are understanding. Done? Then write down third one, astable multivibrator. Astable multivibrator. Astable multivibrator. I'll give you 30 seconds time, then we will see this. Okay. Okay. Now, bistable multivibrator. But for positive trigger to negative trigger, this is the time. Okay. Now, right, same circuit. This is the capacitor, right? This is the PN junction diode. We have to put one more PN junction opposite it. That's it. It will limit both plus V gamma minus V gamma. Done. Now both the states are limited by the capacitor, the PN junction diodes, whatever you have. Right? Now this is what your V0 defined with plus VCC minus VCC. Now we need to have trigger circuit. I am not showing, but this is what is your trigger circuit. Trigger generator. Then we will apply. Okay. We have to apply square wave here. This is input. Now this is trigger input. Trigger input. This is trigger generator. Okay, that is fine. Now let's see the timing diagram, then you'll understand. With this you can say it is done. Now you see here, this is what is our time t, and this is nothing but your voltage across the capacitor. Initially let us say that is 0, right? Initially this is what is 0. We need to start from 0, therefore initially this is 0 volt. At a time t is equal to 0. Time t is equal to 0. Now this is nothing but a comparator. Then initially let us say V0 is equal to VCC, which is 10 volts. At a time t is equal to 0, right? Then let us say R1 is equal to 1 kilo ohm. Same thing. R2 is equal to 1 kilo ohm. Then what is beta VCC? Then beta VCC is equal to 5 volt. At a time t is equal to 0. Therefore now tell me, 5 volt, 0 volt. Plus is more, plus VCC. Therefore your capacitor is trying to charge to 2 volts VCC. Your capacitor is trying to charge to 2 volts VCC. 2 volts VCC. It is trying to charge to 2 volts VCC. But once it crosses V gamma, the diode D1 will come into picture. The forward bias PN junction will come into picture. It will stick, or it will make the capacitor voltage to V gamma. Therefore it will stay there. It will stay there. Therefore this is what is known state, which we have seen already. This is V gamma, right? Now until unless you apply trigger. Now let us say this is trigger. This is your, okay, not here. Okay, this is what your trigger. Let us say this is trigger input, this is trigger input, and this is the output. This is the output, V0. This is V0. Okay. Now whenever you apply trigger, let us say trigger is applied here. Trigger is applied here. Whenever trigger is applied, then the state, whenever trigger is applied, the state will become plus 10 to minus 10, plus VCC to minus VCC. It will stay there. Else, if you don't apply any trigger, this is what is stable state. This is what is stable state. Even the trigger is applied. Therefore, trigger is applied exactly, right? If trigger is applied, because this is V gamma, right? It can go to V gamma. This is what is time t1, let us say. Therefore, it reached at a time t1. It is what is reaching to V gamma. Let us say 0.7, right? This is 0.7 at t1, right? Therefore, once it crosses t1, 5, 0, fine. This is 0, 10 volts only. Your output is 10. But when trigger is applied at a time t is equal to t2, let us say this is what is time t2. Trigger is applied, negative trigger is applied. Therefore, here negative trigger is applied. Negative trigger is applied at a time t2. When negative trigger is applied, which is because this is 0.7, less than 0.7, that is what is enough. When negative trigger is applied, then your output will become minus VCC. When output is becoming minus VCC, which is minus 10 volt at a time t2, then therefore immediately this will happen. This will go to what? But the moment when you apply here, then beta VCC will become minus 5 volt at a time t2. At a time t2. Then this is minus 5 volt, and this is what is 0.7. Then minus is more than plus. Fine, your capacitor is trying to charge to what? It is trying to charge to minus 10. Your capacitor is trying to charge to minus 10. When capacitor is trying to charge to, let us say this is what is your minus VCC, it is trying to charge to minus beta VCC, but once it crosses minus V gamma, because this is what is the reverse bias PN junction diode, this is 0. When this is what is, it is trying to charge to minus 10, but when it crosses minus 0.7, this will be conducting and it will stuck to that. Therefore, your output voltage will be at V gamma, minus V gamma. Again, until unless you apply trigger, we will not get it. Just a minute. Right? If you apply trigger here, again, let us say you are applying trigger here, then until unless, again, this is also stable state. Remember, this is also stable state. If you don't apply any trigger, it will be stable also. Therefore, this is also stable. This is also stable. Now, tell me, what is voltage here? Now the voltage is becoming minus 0.7. Therefore, let us say this is what is T3. This is what is T3. Right? Then it is what is minus 0.7 at a T3. Then what will happen? Now what will happen when this is what is minus 0.7, right? It will stay there only, because what is this voltage? Minus 5. This is minus 5, this is minus 0.7. Which is more? Minus is more, minus VCC. It will stable. Therefore, this is also stable. This is also stable. But trigger is applied, right? To get it, trigger is applied. Trigger is applied. Again we need to apply trigger. But here negative trigger is applied, but here we need to apply positive trigger. Then it will become VCC, which is 10 volts, right? Let us say trigger is applied at a time t, T4. But still this is also stable. Okay? Therefore, whenever trigger applies here, but now we need to apply positive trigger, because this is minus 0.7, we need to more than minus 0.7, therefore we have to apply positive trigger. When you apply positive trigger, we need to apply positive trigger. Let us say this is what is time T4. Okay? Therefore, then it will become what? At time T4, whenever you apply positive trigger, this is what is positive trigger. Okay? Therefore, this is what is time T4. Then your output voltage will change from stable state to again one more state, but it is also changing. Now this is positive trigger. Therefore, positive trigger. This is also entering into stable state. We need to apply triggers in both the cases to change the state of the circuit. Because whenever trigger applies, now your output voltage is becoming plus 10, your capacitor is trying to charge to plus VCC. But again when it crosses V gamma, it will be stable there. Again when you apply trigger, it will go back. This will be continued. This will be continued. Therefore, indirectly the meaning, the period between negative trigger to positive trigger is nothing but what? V gamma to minus V gamma. Now it is not minus beta VCC, right? Therefore, V gamma to minus V gamma, how much time it is taking? Therefore, you have to apply negative trigger, positive trigger in that way. Therefore, whatever time you have, that is what we need to calculate. But the same way, whatever we did in the case of monostable multivibrator, right? Initial voltage V gamma, final voltage minus beta VCC. Sorry, final voltage minus beta VCC. Here also initial voltage V gamma, final voltage minus beta VCC. But at what time it is what is reaching to minus VCC, not minus beta VCC. If you substitute, you'll get the time t. Therefore, what is the minimum time period? Time required between negative trigger to positive trigger, that we can calculate. Okay, I'm not calculating. That is homework for you, which you need to calculate. Therefore, this is what your new time axis t dash. If you take this t dash is equal to 0, and this is what is t dash, which you need to calculate the time t, the minimum time period between negative trigger to positive trigger. That is what you need to apply. With this I can say multivibrators are over. See, these are all self-explanatory. That's why actually the timing diagram is the one which is what is helping you. Okay. Therefore, it is always switching in between V gamma to minus V gamma, V gamma to minus V gamma, like that. Okay. That whenever trigger applies, then only the state will be changing. Whenever trigger applies, the state will be changing, right? Else the states will be stable. Therefore, this is what is bistable. Once output is logic 1, it will be logic 1 only. It is storing the information. If output is logic 0, it is storing the information. Okay. Actually, this is what is our analog logic. This is what is analog logic, but in digital people say what? D flip-flop, right? It will store what? 1 bit of information, either logic 1 or logic 0. That depends on the D input. But how to incorporate the D input? That is what people derive from RS latch, etc. Okay? RS latch, RS flip-flop, or D latch, D flip-flop, like that. Okay? Here the input is trigger. When you apply the input, your output is changed. When you apply positive trigger, output is 1. Negative trigger, output is 0. Therefore, this is what is storing logic information. It is equivalent to digital D flip-flop, sorry, D latch or D flip-flop. Flip-flop to latch is nothing but clock, rising edge, latch, clock level. That's it. Whatever may be, it is storing 1 bit of information. T1, T2, T3, T4 with respect to actual time T, but the new time dash, that is to find the minimum time between triggers, V gamma to minus V gamma. Over? If you want me to continue, that's what I'm saying. It will be in between plus V gamma to minus V gamma. It is trying to charge to minus VCC, but diode will come and then it will limit. It is trying to charge to plus VCC, but diode will come and then it will limit. Therefore, it will be continued in between plus V gamma to minus V gamma, like that. But the change, it will start for every trigger. Whenever trigger comes, you will see the change in the state. Negative trigger, positive trigger, negative trigger, first trigger. Then the state will be changing from plus to minus. I'm just blindly repeating the waveform. Okay, that will be continued. But the minimum trigger period means until it crosses, then the change the state, we cannot apply the trigger to change the state. Okay, that is fine. Now write down classroom work problem 17. Classroom workbook problem. Okay, problem number 17. Assume that Opamp is ideal, and if Vi is triangular wave, then V0 will be. Vi is triangular wave. Then what is V0? Option A, square wave. Option B, triangular wave. Option C, parabolic wave. Option D, sine wave. I think we had seen this already, right? We didn't see it, but we know it. You can solve that. What is this circuit? We had seen, right? Is it integrator or differentiator? This is nothing but what we are taking output voltage. Negative feedback, first order concept is valid. This is 0, right? Then we are taking voltage across the resistor. Therefore, this is nothing but what? Differentiator. But if you have any doubt, quickly you can do. Therefore, this is nothing but 0. Current leaving from this node and the current leaving from this node, right? You know it already, but I am doing it again. 0 minus Vi. What is the current which is what is flowing through it? Let us see into dVc by dt. Where Vc is nothing but here it is plus minus Vc. Okay? Plus current leaving from this node. 0 minus V0 divided by R is equal to 0. Right? Therefore, V0 by R is equal to C into dVc by dt. We know that what is Vc? Vc is equal to 0 minus Vi. Therefore, V0 is equal to minus R into C dVi by dt. Therefore, what is this? This is nothing but a differentiator. This is differentiator. This is what I told, right? Now, if this is differentiator, this is your differentiator d by dt, let us say, and now this is V0 of t. What is input? Input is a triangular wave. Input is a triangular wave. Therefore, it is a triangular wave. Then what is output? What is differentiation of a triangular wave? What is differentiation of a triangular wave? It is like nothing but what? Y is equal to mx. Differentiation of mx, m. Slope of the curve only you will get it. What is slope of the curve? Positive slope, negative slope. Positive slope, negative slope. Therefore, it represents also the slope. Therefore, this is what is the positive slope, negative slope. Differentiation of a what? Triangular wave is nothing but square wave. Answer is square wave. I hope everyone understood. Maybe for your understanding, I can say for the first 0, and let us say this is what is time t by 2, okay, and this is what is the time, this is what is time t, okay, what it may be. This what maybe this is what is time t1 and this is time t2. 0 to t1, this is nothing but what y is equal to mx. Y is equal to mx or y is equal to mx. Therefore, what is dy by dx? Dy by dx. Y is equal to mx is nothing but what? What do you call it? It is a ramp signal. Therefore, dy by dx is nothing but m. That is nothing but slope. Slope is nothing but constant. Similarly, what is slope of this triangular wave? The slope of the triangular wave from 0 to t1 is nothing but constant. That is the constant. Now again from t1 to t2, that is also a triangular or ramp. But what is the slope? Differentiation of a ramp is nothing but constant value, but that is not the slope of that ramp. What is slope of the ramp? But it is negative ramp, negative slope. Therefore, this is 0, this is time t1, and I can say this is time t2, etc. t2 to t3, positive slope again, t3. Therefore, wherever you have positive slope, that is what it is, right? Therefore, this is positive slope, and this is negative slope of your triangular wave. Positive slope and the negative slope of a triangular wave with respect to the time. Therefore, this is nothing but square wave. What is the answer? Answer is A. We should find the type of the circuit. Once you know that it is differentiator, differentiation of a triangular wave, if you know that, answer is done. That is nothing but square wave. Last problem in this session. Problem number 18. Problem number 18. Circuit is given. Everything is C, and given V1 sin omega t, V2 sin omega t. This is V1 sin omega t, V2 sin omega t, and asking for V0. Okay, simple. I think we had seen this already, but what else maybe? Just listen. This is what is our circuit. Can I write it as this is what is our Z? Everywhere it is Z. This is Z. Then you apply nodal analysis, you will get the answer. And let me say this is what is VA and then VB. I think we already solved it. Right? Therefore, when you solve it, what you get? Nodal analysis. This is also Z, right? Everything is Z. But Z is nothing but 1 by SC. That you can write later. And you can convert into time domain. Therefore, negative feedback? Yes. Virtual ground concept? Yes. Therefore, what is this? This is 0. Then apply nodal analysis, you will get it. 0 minus VA divided by Z plus 0 minus VB divided by Z plus 0 minus V0 divided by Z is equal to 0. Z will be cancelled. Then what is V0? Your V0 is equal to minus VA plus VB. That's it. It is irrespective of the type of Z. It could be resistor, it could be inductor, it could be capacitor, but all should be same type. If all are same type, whether it is capacitor or inductor or resistor, but all are same type, then your V0 will be always minus VA plus VB. I told you, right? Summer. Because you are giving input here at the inverting terminal, minus of VA plus VB. That is what you are getting. But what is VA? Therefore, V0 is equal to minus VA plus VB, which is nothing but minus V1 plus V2 into sin omega t. Therefore, what is the answer? Answer is C. This is straightforward. Because you may be confused that capacitor is there, integrator, differentiator, nothing. If C R comes, then only either integrator or differentiator. Only C or only R or only inductor, almost all are passive kind of resistive type of network. Okay, then you can apply resistor. But remember, it should be non-zero frequency. For zero frequency, it is open, 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 nothing. It is open loop. Okay, only for non-zero frequencies, this is true. This is true only for non-zero input signal frequency. That's why he has given V1 sin omega t, V2 sin omega t, which are having some frequency components. Okay, that is what it is. Let me stop. Next session, I can start sinusoidal oscillators. Again, applications of your Opamp, because I am going to use Opamp as an amplifier wherever I need. Okay. Therefore, let's go to the next topic. From Opamp applications, I can say sinusoidal oscillators. Then after sinusoidal oscillators, we have to see regulators, again using Opamp, and we have to see 555 timer. Then with that I can say, therefore we have only 3 topics left. If these 3 topics are over, I can say chapter 4 is over. If chapter 4 is over, then we need to solve workbook problems. Then after solving workbook problems, then we can go for chapter 5. Once chapter 5 is done, I can say we can go for chapter wise test as well as subject wise test. Okay. Thank you.